Hello friends. So today we are going to demonstrate you our work on simile detection using word embeddings and neural network. So coming to the simile detection part, uh, first of all, we are using a BERT model for which we cannot pass text input directly. So what we need to do is convert this text into a vector format which is readable by the machine. So we are converting this word into vector form using BERT tokenizer. So here you can see in the picture, every word is represented as a vector in n-dimensional space, which is fed later on to the BERT model. So let's look into the architecture of BERT model. So first of all, why did we choose BERT model is because it is a bidirectional model which reads text input sequentially from left to right and or right to left. So this is basically a transformer model. Generally, a transformer model consists of encoding layer and decoding layer, which is used for language translation. Since we are not doing language translation here, we are just trying to figure out the similes present in the sentences. We are using BERT model which contains only the encoding layers. So the specific version is BERT base model, which consists of 12 encoding layers, 768 feed forward neural networks, and 12 attention heads. Now, diving deep into the architecture of the BERT model, um, it basically contains 12 encoding layers, and each encoding layer consists of self-attention layer, which output is connected to the feed-forward neural network. Each self-attention layer consists of a number of attention heads, so which converts the words into vector format, and later this vector format is fed into the feed forward neural network, which classifies the sentence as a simile or not. So we can feed the BERT model with three different types of embeddings, that is token embeddings, segment embeddings, and position embeddings. Token embeddings is converting words to vector, which we have shown in our code. So we have used BERT tokenizer for it. Next, my friend will continue with the code part of the simile detection.
So now let us see how we are using the word embedding tokenizer to detect simile in a sentence. So basically what we have done is we have taken a set of simile sentences as we can see here, like he runs as fast as a cheetah, she's as beautiful as a rose. And we have taken a set of non-simile sentences as well, like the sun shines brightly in the morning. So it is simile because it has the words as, fast as, and like. So as and like are present. But here in the non-simile sentences, those are not present. So they belong to the non-simile category. So basically what we have done here, we have divided the data set into simile and non-simile data set by assigning a number to it. So we have basically normalized the data set. So we have converted the simile sentences and given it to as a number one. And for non-simile sentences, we have given the number zero, as we can see over here. So we have zipped this data set, basically combined the simile and non-simile sentences, as we can see over here. That is sentences comma labels is equal to zip of the combined data. So on this zip data, we have randomized the sentences, as we can see here, random dot shuffle, in order to contain simile, non-simile, and then simile, so that there is no continuity in simile and non-simile, just to introduce that randomness in the data set. So on this data set, we have applied the train test split, giving a test size of 30% of the entire data set, as we can see over here. So coming to the training part, we have used a neural network. So a neural network looks something like this. So it has an input layer. There are multiple connections to multiple hidden layers. And finally, these are going to be combined to give the output layer. So here we have used a neural network in order to study or learn the word embeddings or the pattern in simile sentences and non-simile sentences, and categorize the test sentence as simile or non-simile sentence. So in this neural network, we have basically taken the self-attention layer. So we have taken the BERT embeddings, and on these BERT embeddings, we have taken the dropout layer, the linear layer, and on this linear layer, we have also taken the attention layer, which is seen over here, attention mask. So to train this neural network, we have taken certain hyperparameters. That is, max length is 32, batch size is 8, the learning rate, which is actually to reduce the error of the classification, it is being taken over here. And the number of epochs, so epochs is the one complete pass of the data set, that is equal to 5. And so we are going to tokenize the sentence and give it to the neural network. So once it is given to the network, we have tested our model on the sentences as we can see here, like he runs as fast as a cheetah, submit the report as soon as possible, the sun shines brightly in the morning. So these are some of the test sentences we have taken. And upon training, we got the overall accuracy as 100%. But on the training set, there was some loss which drastically decreased upon training for 5 epochs. As we can see here, that overall loss was around 0.1487 compared to 1.9489, which it was initially. So on the first sentence, that is, he runs as fast as a cheetah, is actually a simile. So it said that it is a simile with a probability of 0.94. And the submit the report as soon as possible is not a simile, because as soon as is one more variant which contains as, but it is not a simile. And one more sentence, he fought like a tiger, is a simile with a probability of 0.94. And one more sentence is the cat sleeps peacefully on the windowsill is not a simile. So we have applied one more variation on this similar simile or non-simile sentence, that is on Kannada sentences. So for this, what we did is that we have taken a data set of Kannada simile sentences and Kannada non-simile sentences, like ಅವನು ಚೀತೆಯದಂತೆ ಓಡುತ್ತಾನೆ. Uh, and for non-simile, we have taken ಬೆಳಗ್ಗೆ ಸೂರ್ಯ ಪ್ರಕಾಶಿಸುತ್ತಾನೆ. And for this, the only change that we did was that we have taken a pre-trained BERT model on Kannada words, so Kannada word embeddings. So the one which I have taken is AI for Bharat, and the model is called as Indic BERT. So its working is similar to the BERT model for English sentences, but only thing is that it was pre-trained on Kannada sentences. So employing a similar approach, but making slight variations in the number of epochs, that is, we took it as 16. We got the overall accuracy for Kannada sentences as 62%. So that is because of the word embedding model that was taken. It wasn't as good as the one for the English. As and when the word embeddings model gets better, the accuracy also improves. So, and also for the test sentences like ಬೆಳಗ್ಗೆ ಸೂರ್ಯ ಬೆಳಗುತ್ತಿದೆ. So that sentence is a simile with a probability of 0.61. And for one more sentence, ಅವನು ಸಿಂಹದಂತೆ ಹೋರಾಡಿದನು is a simile with a probability of 0.77. So in this one, we saw how we can detect simile in a sentence by capturing the word embeddings which is present, the similarity in the sentence, the structure which is present, and use that for the classification as simile or non-simile. So now my friend will tell as to how we can use it for hyperpole detection in a sentence.
So my friends have already explained about other figures of speech. Now I'm going to be explaining this other figure of speech known as hyperbole. So what is hyperbole? We need to understand that. A hyperbole is nothing but an exaggeration about a simple about a simple sentence. So basically, an example can be, she is as beautiful as a rose can be a very good example, because nobody is actually like a rose, but they are comparing her beauty to the rose as a part of exaggeration. So this is why it is a hyperbole. We are going to be predicting these kind of sentences. Our problem statement is going to be this: we have a test set with with a set of hyperbolic sentences and a set of non-hyperbolic sentences. So the this stop ಮಾಡೋ ನಿಮಿಷ.
I'll start.
So I am going to be explaining about hyperbole. My friends already discussed simile in detail. So hyperbole is also another figure of speech. Initially, we wanted to classify all for the model for all the figures of speech, but now until now we have done for hyperbole only. A hyperbole is nothing but an exaggeration of a emotion or a sentence. As you can see here, as an example, we have given she is as beautiful as a rose. So that is a hyperbole, because nobody can actually be like a rose, but the beauty is compared to the rose as a part of exaggeration. In Kannada, this is known as Atishayokti. So coming to the approach we have used the KNN classifier, and initially we will have the word embeddings of all the sentences in the train set. given here. And we have annotated train sets so as to the things are labeled like hyperbolic sentences and non-hyperbolic sentences. And there is of course the random shuffling of data so that the hyperbolic and non-hyperbolic sentences are mixed together. And the word embeddings given, that represents the vectorized form of all these words. And the distance metric we have used is the cosine distance. So we need to understand what the distance between two sentences actually mean. So, so let us see the k nearest neighbors method. First of all, we need to understand what the distances between two words mean. Two words or sentences mean distances. Distance refers to what kind of correlation, we can say, correlation a given target sentence has to a given target sentence has to the training set of sentences. So the k nearest classification is also done on the basis of this distance, this correlating distance. So k nearest neighbors is a non-parametric method because we do not pre-calculate any measure or attribute on which we are distributing. It is just purely the data set. Now what we are going to do is we are going to plot the vectorized form of sentences on a plot, and we get points like this, let us say. So this part corresponds to the hyperbolic sentences, and this part this part, let us say, it corresponds to the non-hyperbolic sentences. And if we have a target sentence like this, so the distance from all these points are calculated. These distances are calculated, and this as for the non-hyperbolic sentences also, these distances are also are also calculated, and they are sorted, and the k nearest points are taken. K in our case is 5. If you see the code, k is equal to 5 in our case. So these k nearest neighbors are taken, and the voting is done. Voting in the sense, if this point is the first nearest point, and if the class label of this point is hyperbole, then it will add to the weightage of the class label of this point. So as in the proximity of this point, if there are 5 points, let us say, let us give 2 more hyperboles here, and let us say 3 more hyperboles and a single non-hyperbole, then this point shall be classified as a hyperbole. So in simple terms, the philosophy is like, if there are 5 ducks that are walking, and if the sixth if there is a sixth bird that has no class label, it is considered to be a duck, as it is walking with those 5 ducks. It is like that. That is the philosophy behind KNN classification. And that is we have done the same thing for our sentences also, and we classify our sentences as hyperbole or non-hyperbole. We'll see the code now. We have used KNN classifier as I told you there. This is the code for that. And n neighbors here represent the k value that we have taken. So we have taken phi as the k value, and the metric distance, the distance metric we have taken is cosine distance metric. And yeah, so we have fitted the model upon our training data set and the training labels. And this is the predictions. So the KNN classifier dot predict gives us the predictions of the database. And this k nearest classifier model is taken from scikit-learn of Python. So these are the test sentences. He runs as fast as a cheetah. As you can see, this is also an exaggeration. Nobody actually can run as fast as a cheetah, but this is an exaggeration. And this is classified as coming down. Yeah, this is classified as a hyperbolic sentence. And the submit the report as soon as possible is not a hyperbolic sentence because there is no exaggeration in the sentence at all. So as you can see, it has the sentences are correctly classified, and the accuracy of our model was 0.875.